Okay, let's go over the answers to the acceleration worksheet. This one was probably a little complicated, took a lot of some math, but you're only going to use these two equations. You're going to use the equation for speed, which is distance divided by time. And you're going to use the equation for acceleration, which is final velocity minus initial velocity, divided by the change in time. So the very first question on this, it says, and remember on these, everything on this, you're supposed to be looking at this graph. So you had to download that graph concerning Kim, Sasha, and Barry and their bicycle race. All right. So the very first one there, it says, Barry, we got to calculate his acceleration. And so first of all, I have to know his speed at 0 kilometers. All right. So according to this graph, at 0 kilometers when he started the race, right there, how far had he traveled? None. He didn't travel any distance. So his distance is 0. How long had he been riding his bike? No time, that's 0. So according to the equation that's over my shoulder there, distance is 0, time is 0. 0 divided by 0 gives you a velocity of 0. So his initial, his starting speed is 0 kilometers per hour. I'm sorry, kilometers per minute. Sorry, not kilometers per hour. Now I have to go to 5 kilometers. So we got to look at the graph for Barry. We got to go up to 5. So there's the 5 kilometers right there. So how far did he travel? 5 kilometers, so that's my distance. How long did it take him? So I go down here. Took him 15 minutes. So I'm going to go 5 divided by 15. Right? If I do that and I type that into my calculator, then what I'm going to get is, and here's the equation, 5 divided by 15, I get 0.33 kilometers per minute. So now I know the two speeds that this Barry had. He had an initial velocity, so we can go on this equation up here. His initial velocity is 0, that's where he started. Final velocity is 0.33 kilometers per minute. Now, how long did it take him to do that? Well, it took him 15 minutes to do that, to get up to that speed. So we're going to take, this is actually kilometers per minute. So if we take that, we're going to go 0.33 divided by 15. We get an answer of, let's see, it is 0.022 kilometers per minute, because it's kilometers per minute. Every minute is how much there goes my clock, my lights. Hold on, I'm getting turned on. There we go. So every minute, that's what he accelerated by in this time, right? Now, we could also rewrite this as 0.022 kilometers, and then we got minutes, so I could really go minutes squared, okay? So that's the first one for number 1, is what you should have. Now we go to Kim. All right, so Kim, on the graph, what was her speed at 0? Well, she was still 0 and 0, so 0 divided by 0, that's 0. So she started at 0. And we're looking at 5 kilometers, so we go up here to 5 and go across. So she had a distance of 5. It took her, what was that, 20? I'm looking at it backwards on the screen. That's 25 minutes for her to get to that point. All right. So to do that calculation, we're going to go speed is distance. She traveled 5 kilometers in 25 minutes. You divide those out, go 5 divided by 25, you get 0.2 kilometers per minute as your speed. So her initial speed was 0. So let's go back to this. So her initial speed, 0. What was her final speed? It was 0.2, and that's kilometers per minute. And we divide that by how long did it take her to get to that? Well, it took her 25 minutes. So we're going to take 0.2 divided by 25, because that's what that ends up doing. So when we divide that out, we get her acceleration of 0.008, and that was kilometers per minute on the top per minute. She didn't accelerate very much, did she? Nope, not over that time. And then we can also rewrite that as kilometers per minute squared if we wanted to instead. All right, so that was Kim's. Now let's go to Sasha. So Sasha, what's her speed at 0? Well, same thing as last time. She traveled 0 in 0 time, so her initial speed is 0 again. And then we look at her speed at 5. So we're looking at Sasha, that's this one right here. At 5, we go all the way over to here. So she traveled 5 kilometers in, looks like 35 minutes. All right. So let's go back over to this, and we'll do our calculations. So calculating her speed, distance divided by time, she traveled 5 kilometers, 35 minutes. Divide those out. Her speed is 0.14 kilometers per minute. That's how fast she's going. So now we're going to stick that into this equation. So we have her final velocity, or initial velocity was 0. That's what she started at. What was her final velocity? 0.14 kilometers per minute is what she ended up at after she got to the 5 kilometer mark. Okay. And how long did it take her? 35 minutes to do that. So we divide that out, go 0.14 divided by 35. We get her velocity, her acceleration is 0.004 kilometers per minute squared, because we've got two units a minute. Okay. So going through those again, we've got Barry had an acceleration of 0.022. And you got Kim, she had an acceleration of 0.008. And you got Sasha, she had an acceleration of 0.004. So who accelerated the fastest? Well, Barry did. He got 0.02. Okay. And then second would have been Sasha, and then finally, Kim, and then finally Sasha. Actually, they're in order in the way in which they're written on the paper. So if we actually look at these graphs and look at the angles of these, whoops, I hold it right side up, makes it work better. So we got Barry, notice he's got this really steep slope, awesome sledding hill to ride on. Oh, that means he had a really high change in speed, right? And then we got Kim, her sledding hill, not quite so exciting as Barry, so hers was the second highest. And then we got Sasha, her sledding hill would be really boring, so she's not changing her speed or accelerating very much. Okay, so, all right, now we go to the back side. Now we're going to look at calculating acceleration between 5 kilometer mark and 8 kilometer mark. So now we're going from, let's see if I can do this on here. So we're going on Barry, there's the 5 kilometer mark. Then we got to go up here to where it's 8, that's that spot where they crisscross. All right, so we're looking at what's his acceleration during that timeline. Not all the way to the end, just to 8 kilometers, not to 10. So we've already calculated his speed at the 5 kilometer mark. And that was from the other side. So we found his speed at the 5 kilometer mark was 0.33. That's what we calculated on the other side. So if we want to figure out his speed at 8 kilometer mark, well, what we have to do is we got to go, well, he traveled 8 kilometers, and how long did it take him to do that? So we're going to go, there's the 8 kilometer mark. How long did it take him? Come down here, and it happens to be 50 minutes for him to travel 8 kilometers. So I'm going to use distance divided by time. So here is my distance divided by time. He traveled 8 kilometers, 50 minutes. That's 0.16 kilometers per minute. 0.16 kilometers per minute. So to calculate acceleration, right, so on this acceleration, we've got his initial speed was 0.33. His final speed was 0.16. Right? And then how long did it take him? Well, it was at 15 minutes and 50 minutes. So we got to subtract those two. Right? So it's not the total 50 minutes because we're starting in the middle of the race, actually. So we've got the difference on these is 0.17 kilometers per minute. That's how much his change in speed was. And then how long did it take him to do that? 35 minutes. Divide it out and you get 0.005 kilometers per minute squared. All right, but also notice this happened to be a negative. So because it's a negative, we ended up with that. If it's a negative, what did he do in regards to acceleration? Oh, he slowed down a little bit. And if you look at the graph, did he? Yeah, he did. Here he's like, oh man, he's speeding up really crazy. Then all of a sudden he starts leveling out. So he slowed down some during that time. So his acceleration was negative. Right? He is getting farther down the race. He's actually slowing down a little bit. All right, so now let's go to Kim. So Kim, we already calculated before that her speed at 5 kilometers was 0.2. That's what we figured on the first side of the piece of paper. So now we do it at 8. So let's go here to Kim. So we've got at 8, go across here, it took her 40 minutes to get 8 kilometers. All right. So I go to my other side over here and we go, well, it took her her change. Here's 8 kilometers, took her 40 minutes. So 8 divided by 40 is 0.2. 0.2, her speed is the same as she was. So her speed didn't change. Oh, look at the graph. And look at her line. Her line stays the same going all the way up, straight line. So that does mean her speed didn't change. All right, so now let's look at her acceleration then. So her acceleration is 0.2. That was her final velocity right here, minus her initial velocity, which is 0.2. So 0.2 minus 0.2 is 0. And then she started at 25 minutes. She ended at 40 minutes. So you subtract those and you get 15 minutes. So 0 divided by 15 is 0. So she had no acceleration. Right? Again, her line was straight, so that's why she has a 0 acceleration on this. All right, now we go to the very last one, Sasha. So we know Sasha from the other side. We know her speed at 5 kilometers was 0.14 kilometers per minute. Now we got to figure out her speed at 8 kilometers. So we go across at 8. Here's 8. Go across. She's at 50 minutes. Hey, we already calculated that before because that was the same as Barry, wasn't it? Because Barry up here, he was 8 kilometers in 50 minutes. And look down here, I got 8 kilometers in 50 minutes. So her speed and Barry's speed at that point was 0.16. They're going the same speed at that time. Now let's figure out acceleration between the two times. So we've got, she started at 0.14 and then she went to 0.16. Did she speed up? Yep, she did. How long did it take her? Well, she started at 35, ended at 50 minutes. So we subtract those things. We get 0.02 kilometers per minute change in speed. Took her 15 minutes to do that. So her acceleration is 0.001 kilometers per minute squared. All right. And did she accelerate? So we look at Sasha between here and there. Yeah, initially she was low, and then all of a sudden the angle went up. But overall, yep, she did accelerate. She went faster, right? So we did have a slight acceleration. So I know this is kind of complicated, right? But I got faith we can all do this. Those are the two equations behind me right there. Speed, velocity equals distance divided by time. Then we got this one over here, acceleration, which is final velocity minus initial velocity divided by change in time. All right, so that concludes that worksheet. We'll see you next time. Have a great day.